So this is video 7 looking at the engineering specification for AQA. And again, I've used some revision resources I found from another teacher, Paul Braden, to kind of support with this. But this is going to be looking at structural systems and how they can change and the sort of forces that are applied to them, which will be very useful for your engineering exam. So some of the things that I'm going to be discussing in this are around the load and stress. So we're going to talk about what the difference is between static loads and dynamic loads, making sure you know the difference between tensile stress and compressive stress. And we'll talk a little bit about some of the structures you can get, such as molecule structures and how they are used. So again, I will be, rather than teaching you it, I will be giving you some practice questions and kind of approaching them and giving you some information about how you might address those in your exam. So if you move on, we'll go to our first question and see where we go from there. So our first question we're going to look at is structural systems. What we do here is we would like you to give an example of static and dynamic load. The other thing we're going to talk about is what is meant by tensile stress. So give an example of static and dynamic load and describe what is meant by tensile stress. Pause the video at this point, write down your answer, and let's see what you produce and compare it. So let's start off with the difference between a static and dynamic load. So when we're looking at different structures, we need to learn about the forces that are acting on them. And a lot of the time we apply this to bridges and structures like such. So static loads are known as dead loads. These are the forces that are constant on a building. Okay, so your building is pretty much static, it's standing still, there are no loads put onto it. However, with dynamic loads, these are also known as live loads. These are not constant. They can vary over time. For example, if you've got a bridge, the number of cars going over that bridge will vary from time to time. So it's not always going to be the same load. It may be that you have 100 cars on the bridge one day, or there's only one car in a low traffic period. The other thing that you might consider this is wind blowing. The wind one day blowing at the side of the through the bridge may be very heavy one day, and then it may be non-existent another. So to describe tensile stress, it is the structural stress. Now it can be tensile or compressive, but tensile tends to occur as the result of pulling and stretching. So this is the pulling or stretching. This can cause structural components to become elongated or even pull them apart, depending how the how the force is. There are other stresses that you need to be aware of, such as a compressive force or shear force. So make sure you are au fait with those and you understand them. Our next question asks you to explain the difference between a monocue and a semi-monocue. You also need to state two advantages of using a spaced frame structure. So what is the difference between monocue and semi-monocue, and what are the advantages of using a space frame? Pause your video and check your answer. So, as you can see here, the difference between a monocue and a semi-monocue structure. Monocue structure uses an external skin to support the load. So if you have a look at the picture below here, you can see the wing of, we'll say, an airplane. And what it does is it has some formers, but really what happens is the outside structure, most of the strength comes from the skin on the outside. So older aircrafts used to use this type of structure, and the outer skin was really where a lot of the strength comes from. But with a semi-monocue structure, this is slightly stronger, and as you can see, it's kind of got this underlying frame underneath it, and then the skin is over the top of it. And you're more likely to see a semi-monocue structure in jet airliners, and that's because jet airliners need a lot more stress because of the speed they're going and the high pressure they're receiving. So this is where you're likely to see this. A space frame is a structure that you may see on many buildings because it is aesthetically pleasing. It does make the building look very nice. But actually, the struts that lock together that create that geometric pattern actually give it more, it's able to withstand more stress. So it's a truss-like structure, it's lightweight, and they're used to give a modern aesthetic which make it ideal. The good thing is you can cover a very large space without the need for columns and structures to keep it held up. So it is very, very sturdy and very rigid because of how it's fitted together, and it means that you don't have to have support columns or struts. In this last question, we are asking you to explain what is meant by torsion, but we're also getting you to think about the stresses that cause bending in structural system, the type of stresses that you may use. So pause this video and replay. So, torsion is when a twisting force is applied to one or both ends. So you may see this as when you're opening a bottle. So this is where torsion comes from. So when you're applying a twisting force to one or both ends of the material. Now, when we are bending structural systems, you need to think about where the forces are applied to it. Now, if you had a piece of sheet metal in front of you and you had your hand either side of it and pushed it inwards, that's a compressive force. But what that does is, depending on which way that the material bends, the top of that material or the underneath of it, depending on where it's bent, will have the tensile force, but then the sides coming together are having a compressive force either side. So there's some of the stresses you might see on the structural system. This diagram kind of explains that. So if your hands were at each end of that material, that would be compressive, but where the arch occurs at the top, where it's being stretched, that is caused by a tensile force.